Okay, so welcome tonight, everybody, to the Outdoor Club guest speaker series. Tonight we have the Gavin Christie joining us, and he will be talking about aquatic invasive species in Great Lakes. Before we start, I just wanted to do a quick land acknowledgement for Hamilton. So the city of Hamilton is situated upon the traditional territories of the Erie, Neutral, Huron-Wendat, Haudenosaunee, and Mississaugas. This land is covered by the Dish with One Spoon Wampum Belt Covenant, which was an agreement between the Haudenosaunee and Anishinaabeg to share and care for the resources around the Great Lakes. We further acknowledge that this land is covered by Between the Lakes Purchase, 1792, between the Crown and the Mississaugas of the Credit First Nation. Today, the city of Hamilton is home to many Indigenous people from across Turtle Island, North America, and we recognize that we must do more to learn about the rich history of this land so that we can better understand our roles as residents, neighbors, partners, and caretakers. So to introduce Gavin here, tonight, Gavin Christie is joining us and sharing his experiences as a division manager in Fisheries and Oceans Canada at the Centre for Inland Waters building right around the corner in Burlington. His career has been focused on applying science to support decision-making and protection of our aquatic ecosystems and natural resources. He is also serving on a number of international bodies supporting the Great Lakes Water Quality Agreement and the efforts of the International Joint Commission. I just want to say again, thank you for joining us, and I look forward to your talk. I'll let you take it from here. I think you're still on mute there.
There we go. Good. Thanks very much, Madeline, for the introduction, and thank you all for joining. And thanks for the invitation. And to Hannah, I appreciate that very much. It's fun to have a chance to talk. As I was thinking about it, you poor folks, of course, who have been struggling with the Zoom school all day long and stuff. Now I'm just going to torture you with a nice long lecture. How about? Can I share my screen, Madeline? Can you see that now?
Yeah, it's just in presenter mode, so we can see the next slide in the notes as well.
Okay, I don't want to do that. How do I? Let's see. How can I go? Can I go do this?
Be display settings or
see all slides. Nope. I want to go to display setting. Thank you very much.
Yep. There we go.
How's that?
Oops, I think it might still be sharing this window, so you might have to stop sharing and then reshare it.
Thank you.
Yeah.
Okay, good. Let's give that another whirl. I'm a Microsoft Team person rather than
fair.
Rather than this one, right?
Yeah.
Display settings. Swap presenter view and slideshow. No, still presenter view. What's that? How's that, Madeline?
So you're not sharing quite yet. So you have the window up on your screen, but it's not sharing with us. So just go to the Zoom window and click the share screen.
Got it. Okay. Okay.
You're coming full screen from Ottawa.
There we go. Share screen. 2. Okay. How's that, Madeline?
Not sure if it's just me. I just can't see on my screen.
Me neither.
Thanks. Oh, there it is. Perfect. Good to go.
Yay! That's always good. A small success, right?
Yes.
Anyway, hey, well, again, thanks so much for having me. Thanks for the introduction. I'll be keen to follow on with a bit of discussion as we go here, and appreciate the chance to say hello. So again, my name is Gavin Christie, and I'm a fisheries biologist by training. Work with a number of colleagues at McMaster, but my schooling was done in downtown Toronto. There, at that other school down in St. George. So I'm going to do, as I say, with apologies for the last thing you all need is another Zoom lecture in your day, but we'll do just that and talk us through a little bit about the Great Lakes. I'm going to tell you just a bit to introduce who we are, who DFO Fisheries and Oceans Canada is, and what our science is and what we do. But I'm going to focus today on invasive species because they're really a fantastic challenge to biodiversity across the world, around the world, and then here in the Great Lakes. We have a long history, and I'll tell you about that. We're going to talk a bit about understanding the risks posed by species and where they come from, how they invade. We're going to talk about preventing future invasions, and then I'd like to tell you about how well we've been doing broadly. And then we'll come back to Hamilton and closer to home and end with a bit about what we all can do. My slides have on the top and bottom the flags of Canada and the United States, because we work really closely with our U.S. colleagues and friends on what is the shared border that we share in the Great Lakes. And of course, invasive species come from all around the world, and so it's a global and international problem. And then just to remind us of that as we go. As I was thinking today, thinking all of you, many of you as students and others stuck at home, and probably like you all, I think I need a new pet. And so I found these fantastic guys. I don't know if you've seen these little moss ball pets. They're really fabulous, right? Look at them. They're fuzzy and nice, and you can't, apparently this would be good, because even though as a trained biologist, I can't keep things alive for nothing. So I think it's fantastic. You can see these little Marimo moss balls. Apparently, as you say, with one of those popular plants. They come from Japan, so another animal thing from far away. This interesting algae, and you can see them up in the top right-hand corner there from Amazon. We can get them for, what is that, $19.99 Canadian? Fabulous. And then here, they're mothball pets. So I'm just thinking of you all and folks sort of cloistered away as we are in COVID times. That we really need, I think, mothballs. So anyway, back to business. I was distracted by it. And look at, you can even get socks. And I think a pet with socks, that's a good thing. All righty. Let's talk about our Great Lakes and the science we do. I'll use DFO or Fisheries and Oceans Canada as we go here. You all know this. Here we are in Hamilton. I'm sitting tonight on the shore of the Bay of Quinte at the other end of the lake, Lake Ontario. But what an amazing set of lakes that we live on, right? Really, they're among the largest lakes by area in the world, and by area, Lake Superior is the largest freshwater lake on Earth. Lake Ontario is the 12th, the largest lake on Earth. In the Great Lakes themselves, we have 22% of the surface freshwater on Earth. Remarkable resource. And for Canadians in the U.S. that live on the shores in the basin, over 42 million people, 30% of Canadians, 98% of the population of Ontario live within the basin of the Great Lakes. The economy is fantastic, right? A true driver of what is Canada overall in terms of the scale of the economy and our gross domestic product. And we receive benefits from the Great Lakes, right, from our actions, including shipping here, and these numbers in billions, recreational boating, sport fishery. The sport fishery is literally in the Great Lakes estimated to be worth in Canadian between $2 and $4 billion. It's commercial fishery, there's aquaculture, all of which are benefits, ecological services, you could say, that the Great Lakes provides us. I spent a bit of time thinking about those fishes and what they mean, and you can see the sort of scale and characteristics of capture. I'm really a lousy fisherman, but I work with fishermen and talk and think about how it is that those fantastic sport fisheries that many of you may participate in, or the commercial fisheries here on Lake Ontario. This is on the shore of the Bay of Quinte, or on the south shore of Lake Ontario, and in the middle. And then I mentioned aquaculture. Interestingly, in northern Lake Huron, there's aquaculture here in Lake Ontario. But we know this: the Great Lakes have been subject to just an unbelievable array of stressors, from development to like the marina up in the top right, to the industrialization, to the impacts of shipping, and then our theme through, which will be on the impacts of invasive species like the sea lamprey mouth that we see in the middle, and then zebra mussels on the other side. Tackling the challenges in the Great Lakes have involved folks working together. I mentioned this, working across the borders, and we really lead the world in what is international collaboration and cooperation. The Great Lakes Water Quality Agreement, which was first signed in 1972, just most recently revised in 2012, focuses the attention of both countries on protecting the water quality of the Great Lakes. In 2012, we added aquatic invasive species to the Great Lakes Water Quality Agreement as a focus of that work. The Canada-Ontario Agreement, which has just recently been renegotiated, as well as a domestic action plan between Ontario and the Canadian federal government around protections of the Great Lakes, and includes aquatic invasive species as well. And then the Great Lakes Fishery Commission was established in 1955 with a focus, interestingly, on invasive species, on protecting and prevent and controlling sea lamprey, which are devastating and invasive, and I'll tell you more about that. And the other activity that the Great Lakes Fishery Commission does is help look at how we can coordinate management across lakes, because of course the natural systems and ecosystems of the Great Lakes and the invasive species that affect them don't observe our borders. So our laboratory, I'm with the Great Lakes Laboratory for Fisheries and Aquatic Sciences, and we're, as Madam mentioned, we're in that here at the Canada Centre for Inland Waters, just around the corner from you on the isthmus that divides Hamilton Harbour there. We're co-located with Environment and Climate Change Canada there. We have part of our group works up in Sault Ste. Marie at the Great Lakes Forestry Centre in Sault Ste. Marie, and then we also have some of our team is based in Winnipeg at the Freshwater Institute in Winnipeg on the campus of the University of Manitoba. And my group, I'm just really blessed to work with a fantastically committed group of scientists and biologists and technicians that investigate and provide science to support the actions of Fisheries and Oceans Canada. Fisheries and Oceans Canada is a federal agency that delivers the Fisheries Act, which is the legislation, the oldest legislation in Canada to protect, and we work to protect fish and fish habitat from development and change in the ecosystems. We do science to help with that. We also support the Species at Risk Act, which of course is involved in protecting rare species or species that are endangered. I mentioned we do science to support aquaculture, freshwater aquaculture, to ensure the sustainable and the environmental effects are minimized. We do quantitative ecology, that is thinking about how we make predictions, and you'll see some of that as we go down and talk about invasive species. Ecosystem science, trying to understand how food webs work in the Great Lakes, fish and fish habitat, as I mentioned, trying to understand the impacts of development on fish habitat. And then, of course, really importantly, invasive species. We do invasive species science and play roles in providing evidence for decisions and management of aquatic invasive species. So let me talk a little bit about invasive species and the history of devastation. So, unlike other changes in the environment, one of the impacts of invasive species is that, of course, once they're in, they're there for good and often very hard to get rid of and have long-term effects. And so we'll talk a little bit about those. There's a wide range of them. Up in the top left-hand side here, the sea lamprey, invaded from the Atlantic Ocean, was its home through canals to the seaway. Sea lampreys are parasites on fishes living in the Atlantic Ocean happily with their larger prey, but here in the Great Lakes, chewing holes in fishes like up in the middle here and killing freshwater salmon and trout species, the native predators, eliminating those. Other species that we are naturalized in the Great Lakes, we'd say, or were invaded a long time ago at the turn of the 1900s. Alewife, shad-like species, herring, also from the Atlantic coast, got in through canals, to the Erie Canal, we think, and that organism has affected the prey populations in the lake very greatly. And then zebra mussels. all of us have seen zebra mussel shells on the lake. They got into the Great Lakes through ballast water of ships coming from the Baltic Sea. And those organisms, origin here in North America, here in the Great Lakes, have caused fantastic changes. We think of them as re-engineering the ecosystem. The picture in the bottom left here of algae and it's Cladophora. It is a filamentous algae, and the way that nutrients are moved in the system, and the way that light penetrates the Great Lakes, the clarity of water, have been greatly affected. And the impacts of those are some of those algal blooms and those rafts of dead algae that we have on the beach just in Hamilton and we have elsewhere are caused by, we believe, the impacts of this invasive species. As well, they have a variety of effects, including plugging up pipes and just changing the whole system and how it works. Other organisms, interestingly, the round goby here up in the top right-hand side, that animal came with or followed shortly after from ballast water too, we believe, and is an organism that is co-evolved with zebra mussels. Happily, they eat zebra mussels a little bit, which is a cool thing, but they have disrupted a lot of native fishes and really changed darters and others, and are a food now for other organisms. They change the way that toxics are reorganized. And I mentioned food webs. The animal up in the top right-hand kind is called a spiny water flea. It's a small crustacean that lives in the water, and zooplankton. And those zooplankton are key elements of the food web for native fishes. And these guys, with their long spines, are difficult to eat and have had great impacts. Well, those organisms came from a whole bunch of different roots here. Some species like Pacific salmon in the Great Lakes, Chinook salmon that we know, or rainbow trout, we planted ourselves, right? So the planting part here, the green bar in the middle, are planted at the stock. But the rest of them are organisms that got in on their own, and lots of them are invasive. And notice that blue bar on the bottom, that's from shipping. And look at the kind of scale of those things. And you can see the escalation. After the Seaway, we created the St. Lawrence Seaway back in before 1960. After the Seaway was opened, you can see the rate of those of the total invasion population just increased dramatically. So the impacts and zebra mussels on the top of those, but the numbers of organisms are huge there. I mentioned before that aquatic invasive species are noted across the globe of affecting biodiversity and are really a key impact on ecosystems. And today, when we look across and try to understand the impacts of stressors on the kind of threats that I described earlier to the Great Lakes overall, from things that affect our drinking water to the disruption of our beaches, toxic and disrupted fish consumption, toxic chemicals, disruptions of habitats, algae that we just were describing, impacts on groundwater and other watershed changes. You can see when we do a scorecard, we do a scorecard every 3 years, and this is the most recent scorecard, which was just relatively recently published by Canada and the United States. And you can see, look where aquatic invasive species rank relative to the rest of those stressors as one of the worst stressors, and also still continuing to be a negative. We'll talk about the negative aspects and talk about some successes as well. So key to knowing how to respond to a threat like that is to understand the risks posed by individual species or by their pathways. Because by understanding the risk, we can understand which animals or organisms we want to prevent, and then also by understanding pathways, we can decide where we can focus our efforts. So what do we need to understand about which species pose the greatest risk to the Great Lakes? Well, we need to understand if a species can arrive. And on the right-hand side of the slide, I provide some data and information about Asian carp. And you might have heard of Asian carp. They're organisms fishes that were brought from Asia, big-headed and silver carp illustrated here. And those two species were brought over to enhance aquaculture practices in the southern United States on the shores of the Mississippi River. They controlled algal populations and other elements, and were raised for food. They escaped those ponds and have escaped into the Mississippi River and threatened the Great Lakes from there. And we'll talk a bit more about it as we go. But we here in the Great Lakes, we had to understand, are these guys potential hazards to the Great Lakes? Do we need to worry about them? Well, can they arrive? Well, I mentioned they found their origin in the Mississippi River and are swimming up the Mississippi River, and we'll talk about the routes that connect the Mississippi River to the Great Lakes. So yes, the answer would be, can they survive? Well, the graph at the top there is the temperature tolerance of these animals. And I know when we first heard about them, we thought, well, they'll be more southern, South Asian, but they're not actually at all. You can see that the climate match, we call it, could these animals live in freshwater habitats? The red bar says absolutely they can. So then we need to understand whether they could reproduce, and they were assessed. We have assessed and done studies to understand whether they spawn in streams and whether those streams could support their reproduction. The answer to that is yes, they could. And if they get in, would they spread? And we did modeling and research based on their habit and habitat to understand whether they would. And the answer is yes, they would spread. And then what harm would they cause? Well, they by their intense feeding on lower trophic levels, lower parts of the food web that I just mentioned, they would definitely cause impacts and effects. So we do a map essentially of the risk associated with them, look at the magnitude of consequences of these animals, and then the probability that they'll actually get in. And you can see that says to us that when we look and pull all those data together in models and make those predictions, that the organisms provide quite extreme threats, and there's a very high risk that they would introduce unless we take action. So we'll come back to that. And so we took a look at those at bighead and silver carp. The other two Asian carps are black carp and then grass carp, which is currently in the basin. We'll talk more about that. And we consider other species like this is the snakehead, which is an organism which is found in Washington D.C. and some other locations, brought in through trade. This animal is an amphipod crustacean called a killer shrimp, which we've yet to see, but it would have the potential to very much to spread and survive. And this is a water chestnut, an aquatic plant brought in water gardens, and it has the potential to very much spread through the system. So all these animals would be seen to have high risk. So the Asian carps, all in our work on assessing their risk, come out as being high risk, as I just described. And so do these species, as mentioned. So we'd say these are high risk species. We want to take actions to prevent them. But then, interesting, when you do that screening, some animals, while being not native, don't pose risk. So Siamese fighting fish, another one that could live right along with our moss balls in our tanks. Those guys are not a risk today because their habitat match is such that they couldn't survive here in our Great Lakes. So we do not consider them a threat as an invasive species. The next challenge is to understand where or how could these organisms get in. We talked about which species are at risk. Well, how could they get here? So on the Asian carp story, I mentioned that in the middle there, you can see the states down in Mississippi, Louisiana, in Arkansas, where the aquaculture took place. Those animals escaped up the Mississippi River and populated the Mississippi River up the way. Well, it turns out, and you all may know this story well, but interestingly, in Chicago, back before the turn of the last century, faced with the problem of pumping their sewage into Lake Michigan, where they were drawing their drinking water, they took a great civil action. And the continental divide that divides the Great Lakes drainage from the Mississippi drainage is very close, and you can see that stippled line here. The brown in the map there is the Great Lakes basin, and then the green gray is the Mississippi basin. So they cut through the continental divide and pumped their sewage down through the Chicago sanitary and ship canal into the Mississippi River, and that diversion which is now used very much for shipping, for trade, is a canal that would allow Asian carp to enter the basin. So our studies of the risk point to this being the greatest risk. And happily, there's an electric barrier and other actions taken to prevent these animals from getting through that spot. We'll talk a bit more about that. Other routes include trade. I mentioned the aquatic plants and aquatic plant trade, and so we've done. Folks have done research and science around estimating what those trade routes are. There's live trade in fishes for food. In fact, Asian carp that we were just speaking about were brought across the border live for food purposes until very recently, and I'll tell you about that change. And those risks are real, and we'll talk more about them. Here's down in the bottom left is a conservation officer checking on shipments of aquarium plants. In the middle is a picture of a live fish truck moving live fish either for pond introductions. We have the ability to buy live fishes to move around between ponds or for food. And then in the bottom right, folks have developed, with my colleagues at the Great Lakes Commission, have developed tools to look for organisms in trade. Talk about more about that. So another pathway, a huge pathway, is shipping. And scientists in my group work on understanding the risks of ships and ballast water. And this is a point of great success, and we'll talk more about that as I go along. But we've done the work on where those ships come from, where the organisms in them are, how those organisms survive, and then really importantly, what can you do to try to eliminate them? And then there have been actions taken, and we'll mention those. And currently we're working with Transport Canada around new regulations under the Shipping Act to enhance those regulations, to take on a global effort to treat ballast water in all ships, including Great Lakes ships, to reduce the introduction and spread. But lots of routes can be routes of invasive species. Here, recreational boating is also a way that organisms can move around. And I mentioned our scientists do the kind of quantitative modeling and estimates of how many boats there are, and if they were to get if organisms were to move around, and what that would mean, and have done some work on the risks of recreational boats moving aquatic invasive species around too in the Great Lakes. So our work is focused on trying to respond or prevent invasive species. If you can prevent them, then we can stay in this place where they remain absent. And you'll see on the right-hand axis, vertical axis, we've defined the control costs. So what does it cost? Well, prevention costs little relative to the impact overall. But if you find yourself up trying to control something, like we do sea lamprey today in the Great Lakes, it can cost millions of dollars. In fact, the sea lamprey control program in both countries costs around $30 million a year to execute control to suppress that animal. But on the curve, where prevention, not allowing them in the first place, is the key idea, then if they were to occur, then we might have the potential to detect them and respond to eradicate them, or we might be able to contain them from spreading before we were faced with either adapting or coming up with some long-term management program. So I'll focus a bit on our Asian carp program, because I work with a great team of folks who in Fisheries and Oceans Canada, who carry out this work and work with the province and work with our colleagues on the US side, the US Fish and Wildlife Service, US Geological Survey, and the states to carry out this critical work. And the idea there is that if we can detect them, and we using the risk assessment that I mentioned earlier, we evaluated where would be the highest probability spots where these animals would occur. given the habitat and given their spawning needs, and where they would occur. And we carry out a rigorous assessment using electrofishing boats. We sample fish using electric currents in the water, using nets. This is a hoop net in this case, and then some fish for larval fish with these nets in the bottommost image here. We've developed new tools to look for invasive species as well as those traditional tools. And really interestingly, folks have found that just like CSI, fishes leave DNA around in the environment, and so we can sample water and then look for a target DNA or markers of the occurrence of those animals. And so you can see on the sample sites here, the U.S. Fish and Wildlife Service and our partners in the province of Ontario carry out sampling using water sampling and environmental DNA to look for positive sightings of fishes. It's one of the tools we use, and we respond with other sampling to sort of verify whether they'll be there or not. It's a really interesting new tool that's there. So I've described the part about looking to detect there, but then what if we found them? What would we do? Well, we've done a lot of work on responding with the Asian carp species. Where only tool that we have in hand today is more capture and netting and capturing enough of them that we could eliminate them. We're also interested in working on barriers to their spawning sites and other actions like that. But to put that in place, like emergency responses, we're treating invasive species like a hazard in that way. So the occurrence of the animals would bring us all together, and we'd execute a response work overall. And so I've got a couple of images that support that, including work that we've done on Lake Erie, working with our U.S. colleagues there. And this is what that response looks like. In this case, this is my friend Dave Marzan here. We found a population of grass carp, which is the one Asian carp species, a bit different than the others. In agriculture, they're used to eliminate. They eat vegetation, plants. So you can imagine the impact they'd have if they ate the weeds that are the habitat of fishes around the Great Lakes. And those guys were found in a pond near Welland, Ontario, in the Welland Canal drainage, actually. And we were able to, by once they were found, to respond really quickly with intensive fishing and have go back and check out. And we haven't found more of them, so we believe that we were able to eradicate that small population there. We can test to understand the status of the animals and use samples to do just that as well. Grass carp, some are able to spawn and some are not, the way they're used and the way they can get into the lakes. I mentioned the Chicago area waterways system. Here's Chicago. Here, this is the shore of Lake Michigan, and the canals, as mentioned here. There are some important spots where we have sites of the electrical weir, which blocks the animals, and then we have a response. Our U.S. colleagues and the collaborating states and federal agencies have a plan set up so that with this intensive monitoring upstream, they can respond immediately and do so, and have done so at regular intervals in recent times to capture and eliminate any of the animals if they get above that barrier. Well, any action like this, I've talked about the actions we could take, but invasive species, just like everything, are the basis for those actions are regulations. So I mentioned the part about just a simple way to think about it, bringing live Asian carp to market. Well, they pose a real threat. So through regulation, by installation of regulations under the Fisheries Act, new legislation in Canada, we ensured that those animals cannot be brought into Canada unless they're dead. Pretty simple idea, but kind of an important one that could really affect the risk of their introduction. We established just only relatively recently federal regulations under the Fisheries Act back in 2017 that are important new tools to support prevention. And same in Ontario, they have an Invasive Species Act, which applies to both terrestrial invasive species and others that prohibit organisms, and then also allow some actions, and then prohibit and allow pathway regulations that I've mentioned to you all. And then on the other side, same thing, federal regulations and state regulations come into play. A theme that I've mentioned with the flag borders is that we're working together across. Well, that's a whole range of both federal, provincial, and then international agencies. And I mentioned the Great Lakes Fishery Commission earlier, Great Lakes Commission, the International Joint Commission, are all institutions that play part in this, and we work together in committee form and in interactive forms to ensure that we can respond and react. Invasive species management relies on science, of course, direct science, to look at tools. We mentioned the assessment side of that story, the detection side, those eDNA tools, developing markers, and then there's new research going on today around real-time markers, just like a rapid test for COVID, something so we can just go in and people can look at a fish tank and test it and understand whether there's a risk or not. Science to develop barriers, here using sound, complex sound, or carbon dioxide as barriers are being tested, and they're part of a new development on that Chicago waterway that I mentioned there. Asian carps filter feed a number of them, the worst ones, and so we've been looking at applying pesticides that would be toxic to them in little cells that only they would eat. Really interestingly, coated in proteins that only their stomachs would break down. Fascinating technology to be doing. And at CCIW, this is an aerial image of Canada Center for Inland Waters. There's the canal out to the lake, the open lake there in the Skyway. There's a slip that we've used to do science around containment and disruption using light and sound to try to contain species. Of course, we're not using Asian carps, but we're using surrogate fish, common carp in that situation to examine and test new techniques. So I've told you a lot about the downside, and I'm going to talk a little bit more about that, but there is some upside here. So I started with this image, which shows the different colors being the different routes by which organisms have entered the Great Lakes and caused the damage that we've talked about. And if we look at that, and we currently say that there are estimated non-native species, over 184 non-native aquatic species in the Great Lakes. And then really importantly, we look at that pattern after 2006, where both countries got together and took a simple action. Simple is an understatement of having ships that are coming into the Great Lakes from in the seaway, from offshore, exchange the ballast water with seawater. So they're picking up ballast to balance the boats and their loads in ports, freshwater ports or brackish water ports. So by exchanging that water with open sea salt water, that salt water kills a lot of the organisms there. Not all, but quite a few. And we see a change in the blue element of the graph here, which is the shipping piece, and that relates to that success of that effort back starting, as we said, in 2006. We're taking new efforts based on international efforts to control organisms further by putting treatment in ships, and we're examining those techniques. We can see this is the same figure, really, just illustrated a little differently with the rate of invasion by decade here. And you can see, remember we talked about when the seaway opened back in 1958 or so, in the middle of the figure, you can see the high bars after that time where annually there were a large number. And then look at this, after 2006, we see a decrease in the rate of species. So we'd say that's a story that's painting a picture in all the lakes of being positive, green. But it's not 100% the case, because we found in recent times in Lake Erie in the 2017-18 new species of zooplankton. We yet to know their impact or effect. And then a fish species called the tench has just relatively recently, in the last 3 years, been detected here in Lake Ontario, in fact, right here in the Bay of Quinte. So the door is not closed, which is a challenge to us. we measure the effects that we've talked about, by looking at those impacts. And look at this. There's the goby again. There are invasive crayfish like the rusty crayfish, the spiny water flea, zebra mussels, and we haven't seen Phragmites, which is that tall Asian rush that we see on roadsides and in waterways. And we've done work with our U.S. colleagues on the other side of the border, looking at the pattern of impact there. And when you map that from 1950 on, where you say the number of bad species that are found in water in drainage basins, this is the kind of pattern. And look at the change in color where darker red is greater effects. And so we'd say that the impact of aquatic invasive species continues to be negative in all the Great Lakes. I mentioned zebra mussels, one of the original devastating species that have entered the Great Lakes from shipping. There are two species, zebra mussels and quagga mussels, and this figure illustrates in Lake Michigan, in this case, the expanding density of those mussels on the bottom of Lake Michigan, and where darker is more, starting from there before they were found in the 1990s. And we see those effects showing really devastating increases, that is more poor outcomes in Lake Ontario and the other Great Lakes here. Lake Superior, not so much, because those animals rely on salt water and calcium for their shells, and that's found in the lower Great Lakes. I've mentioned sea lampreys. Sea lampreys got into the Great Lakes through the canals, through the seaway, and we have a large program I've mentioned that started back in the late 1950s to control them by eliminating the larvae in streams by applying pesticides. And these figures look at the abundance of larvae of lampreys in the lake relative to target levels that we've set, where the damage to fishes we believe would be less. And you can see that there are some pretty positive stories here, given that the good work of my friends that do the sea lamprey control program. So let's come closer to home, to Hamilton, and then think a little bit of what aquatic invasive species mean to us and what we can do. Hamilton Harbor is a Great Lakes area of concern under the Water Quality Agreement, really degraded, of course, by all the industrialization and urbanization around it, and a whole series of important negative effects. But Hamilton Harbor, and any of you that spent time there, you know how rich the ecosystem is, because the efforts that we've done to restore those habitats we've had some really strong successes. I'll talk a little bit about those, and they've really been quite positive. There's some huge projects going on, really fantastic ones, like Randall Reef, you might have heard about, where the last of the large toxic contaminants are being capped in place in the lake, which in the harbor. So we made real progress. The areas of concern are a place that we focus restoration efforts in the basin. And but I'll bring your attention to fish populations. In the areas of concern, we measure our success by evaluating impairments and then working to try to improve those impairments. So the goal in Hamilton Harbor is to create self-sustaining communities of mesotrophic as a way to characterize that cool water embayment, which is such a productive spot on Western Lake Ontario, with a balanced trophic level, which means balanced food webs with strong top predators. And we see a walleye up in the top there with Hamilton in the background and northern pike. And the impacts on those fishes have and how we would attain those through water quality restoration, the important work that's being done on sewage treatment in the harbor, habitat restoration. We've done work on creating aquatic habitats in a number of locations. Stock restoration has been worked by the province to stock walleye, to put a seed in for the population to restore that native species. And then to deal with invasive and non-native species. The key animal of concern is the non-native European carp, common carp. Different than the Asian carp that we mentioned, we brought a European carp over, or settlers did, back in the late 1800s. And this fish loves wetlands and digs them up. So Coote's Paradise is a fantastically rich, shallow wetland that runs right up to you at Mac there, as you know. And and it's been greatly degraded by water quality. There's work being done on the sewage treatment plants, but carp have ruffled that up such that the habitat is degraded because because the plants can't grow there. So in front of Coots Paradise, there's a fish barrier that was built back in 1996 to preclude common carp from entering. And it actually has a fishway. If you've been able to go see it, it's fantastic. And they run it to keep carp out. And then up the grindstone, there are a number of barriers and carp exclusion efforts there to keep them out of those ponds as well, to try to keep the invasive species, the carps out, to restore vegetation and the key habitat, nursery habitat, and others. So good fish are passed up. Well, that story has gotten more fantastic. We see this is the blue line here, vertical line in the graph illustrates when the carp barrier went in. And look at what happens to European carp. They're declining at a significant rate, really an improvement. But look at this, goldfish, right? Increasing. And look at the size of these guys, right? So these are goldfish that are coming out of your, that people are letting go essentially into the waterways. And so my friends, Christine Boston and John Midwood at the lab are studying the goldfish that to sort of understand where they go, using radio tags down at the bottom, right? As a little radio tag. And we have acoustic receivers, and like we're looking at the other fishes as well to look at the restoration of the fish community and watching where they go to try to understand their patterns and their impacts on other fish. So goldfish, don't let your pets go. And that's the thing. There's a whole series of actions. We've talked about the big scale actions, that is actions that are being done by governments and others to prevent, but we all have a role. So I've mentioned the Asian carp piece. Just seeing Asian carp or possession of live Asian carp being illegal has been noted. You might have seen this billboard in recent times. My friends at Ontario Federation of Anglers and Hunters have a great a tool so that if you see something unusual when you're out and about, really key to be able to sort of report it. And ED Maps is an app for your phone, and you can actually snap a picture of an organism if you don't recognize it, and we can tell whether it's an invasive species. That early detection would be key there. But I mentioned the part about letting your pets go. Well, here's that just laid out in a program on the other side called Habitatitude, which is really focused on not releasing your pets, right? So those goldfish, as we mentioned there, and then key, and for us and for you all in the Outdoor Club, a key idea is the idea of stopping aquatic hitchhikers on your boat with clean, drain, dry. Both boats, of course, right? Your canoes, but your waders and fishing gear if you're moving between and among waterways. A key idea, right? Just simple. With no water, you're not going to move aquatic organisms around. A straightforward idea, but a really important one that we're really interested in everybody doing, and we all have an opportunity to do that. Yeah, hey, remember those moss balls? I mean, I'm just really captivated by them. And but this is amazing. Just this week, in fact, at the start of the week, I learned that from my friends in conservation protection, they were responding to a really important finding that was found on the U.S. side in Seattle. A pet store person, as she was putting all her cool little moss pets in an aquarium, found zebra mussels in them. Well, I mentioned zebra mussels in the Great Lakes. Zebra mussels have not yet spread all across North America and are a great threat across Western Canada and across the United States. And here are little moss balls, and their cute little adorable friends have potential of carrying zebra mussels. So our invasive species program is reacting, and conservation protection working with border security to try to eliminate them from movement, or try to help work with pet stores to ensure that they're going away. And remember my friends at Mossball Pets there with the cool socks and things? Well, they're doing a good job on their website. At the top there, you can see that they're no longer available, and they've responded by taking action to not move them around. It's also another great example of working across borders. That is, we have a great communication network of folks who identified them and then communicated this all around. And so all the jurisdictions are taking action about those cute little mothballs. Okay, so that's what I've had, and more than long enough talking. Just a good old another lecture for your evening there. So I'd be happy to talk a bit if you want to take a bit more time for questions.
That was great. Thank you. if anyone has any questions. I think I've seen a few like comments in the thing here. It looks like Francis had mentioned earlier that the Alberta Wildlife had seen that, so it's funny that you brought that up
Nice.
at the end there.
Great.
So yeah, it's open for anybody to type your questions or unmute yourself or turn on your camera. It's up to you.
Hi, it's Tom from Ottawa.
Hi, Tom.
I noticed on your chart, the invasive species, there was a high bar in 1938, 39, and before and after that, it's lower. What
Mhm.
was the cause for that peak in the 30s?
Yeah. Turns out, and remember we mentioned the part about folks interested in introducing animals, Tom, and so there's a case where folks were moving around non-native animals a bit. So a number of those were cases where folks were purposefully introducing animals. Now, some of that was in response to, we were already seeing some of the degradation in the Great Lakes. So folks were looking for alternative organisms. That's a bit of the explanation, not the full. That's part of the variation that we saw, you know, in those numbers broadly. And then interestingly, you know, we've found that a number of things that have gotten in through the early canals. Remember, the Erie Canal up from New York was opened much earlier in the 18th century, and 19th century, and so there are a number of different routes. So that's part of that explanation.
I see.
Yeah.
Great, thanks. I had a quick question. Oh, go ahead, Francis.
Hi, I just had a question. Like, I'm a really avid like fish keeper and aquarist, and over the summer, like I guess I'm quite guilty of keeping like invasive species as well, like especially plant species. Like I know water hyacinths are like really prolific invasive species, and I had them over the summer as well, and like other little mini plant life like Sylvinia minima, because I know they're not from here, but they look really pretty, right? So a lot of people buy them for aquatic purposes. But I suppose my question is like, if people like me want to dispose of like their aquatic plant life that are not native to the region, how do you suggest we should do that?
Great question, and there are others that could answer better than me. There are some in some jurisdictions, and sometimes folks do swaps and open swaps to aquarists or whatever to trade in or to hand over their organisms if they're not about killing them themselves, right? So I would say that the main piece would be then, well, the thing you could do, and again, for friends, if you look at the articles on the Mussel story, right, is that of course you could folks would be asked to not release them live, and if you do want to dispose of them such that they're no longer alive, right? And so that's not the happiest way to put it, but it is the case. And I know, like anybody, right, you know, as a kid I certainly flushed my goldfish down the drain because I didn't want to even though I was sick of looking after them, and didn't want to care for them any longer. Now, they probably didn't do so well going down the drain, but that's not even the right answer there, right? And then worse, people do release their pets because they have a sense of a living thing. And it's possible to keep and contain. So water hyacinth's a good example, and there is our water hyacinth location there. We're a bit on the climate bound of water hyacinth, but they are some in New York State and in the Buffalo area that folks are acting on today. So you're right to identify that one as an invasive. And so what we'd say is that you could contain, but what the direction, you know, the ambition would be to make sure that your organisms are ones that they can't escape, right? You know, that you're not allowing them that way to get out. And then that's you know, comes back to the pet industry and to aquarists and hobbyists, and to the agencies involved to then bring in those regulations and say, you know what, if something's really high risk, then let's prohibit it so that it's not at risk of escaping from your tank.
Okay, yeah, that's what I did. I let them die off, like I let them dry off in the sun, and then I put them in a food waste bin.
Yeah, yep, that'll do it. And in most cases, of course, that'll be completely fine and more than adequate. Yeah.
Okay, thank you.
You're welcome.
Great, thanks. And Christina has a question.
Hey, Christina.
Hi, I was just quickly wondering about how the intersection of invasive species and climate change has been working, because I know
Nice.
with the increasing rates of warmth in northern areas, I would expect to see invasive species kind of following, as their habitat is now closely matching what we're noticing happening in northern areas becomes more southern beneficial to them, right? Do we notice that in warmer years we have more invasive species?
Great. That's a great question. And I've been finally, when I, even though I gave you a billion slides, I took out a few, and some of them were on just that, on the science around that topic. I got friends that have been doing exactly that kind of work, Christina, looking at what the change in that risk could be. On a given year, yeah, you'll see a little bit of that, potential. We our tools for identifying when things come in and when they occur are a little coarse to understand whether that's a warm year or cold year. But what we are seeing is that shift in species distribution and core climate, as I mentioned, say when I was looking at that risk assessments for the Asian carp species, is kind of a key starting place. That is it warmer enough or cold enough, or too cold for organisms? And just as you've suggested, we're seeing a shift in that which allows or puts organisms that wouldn't have been at risk before, now at risk. And we see that shift. And so folks are working on just that, on building those maps essentially to say what areas would be more at risk as we see climate change. But you would definitely put it in the category of one of the potential impacts of warming or climate change broadly. And then interestingly, another feature we know for climate changes, Christina, is increased intensity of storms, right? And the impacts of those intense storms can mean flooding events and connections of waterways which would have been separated otherwise, or overcoming banks, etc., which can spread organisms around.
Yeah, thank you very much. I was wondering about that because I remember hearing that invasive species tend to be worse as climate change is accelerating.
Sure.
I also had a quick question about, you were talking about spiny water fleas, and I did a little bit of study on water fleas of a different variety, but I know that they're a food source for so many other creatures. Do we notice that kind of more larger invasive species follow smaller invasive species populations?
That's a neat question. Certainly, there are some of those connections between organisms that follow that where one actually matches another, and some of the source locations where organisms come from are the same sources, right? So a number of the organisms, zebra mussels included, and then the gobies that I mentioned, and then some of those zooplankton, Christina, come from the Baltic Sea or Northern European harbors or estuary areas. So come from the same areas, so you can move organisms around that are related to one to the other. So to that question. But invasive species are often invasive, of course, because they're moved from an area to a new location where they don't have predators or competition that they're used to, and thus expand in the environment. And then back on the water flea side, you're absolutely right that larger zooplankton are then sort of broadly speaking are better food. And in our system, larger zooplankton drive the food web essentially in terms of fish productivity. But the large water fleas that we mentioned, the spiny water flea and water flea, those guys are so big and then have those spines for protection from fishes that some of our native fishes don't eat them as effectively. And then secondly, they're also really aggressive predators on other zooplankton, so they're disrupting the food web themselves. So there's some arguments are made that they've actually been key elements in what would be kind of bottom-up changes in food web disruptions that have led to things like changes in the dynamics, say in Lake Huron, where we've seen real changes in the prey fish populations. Yeah, good questions.
Yeah, thank you very much.
You're welcome.
I had a question about I found it was really interesting, the microparticle pesticide that you were talking about. I thought it was really cool strategy, and I was wondering what the sort of protocol is, what the plan is for when it does work. So do you go in and have to like mechanically remove the dead fish? What happens with all the leftover little particles that aren't eaten? Like, how does that affect?
Yeah, great question. And I can tell you that still in the seeing if it'll work place, right? Okay. Right. So the idea, and it's really fantastic, just like coating your aspirin with a coating that dissolves right in your stomach. Now that would dissolve in any water. Well, they've actually developed some coatings which are reactive or respond only to certain enzymes, right? So actually, you can tailor the particles so they'd actually release only then with the gastric enzymes of these specific fishes. Pretty fantastic. But that it's really out there in the kind of in the bit of a distance, or that is we're still working. Folks are working on that. By we, I mean global we. And the concern about what would happen to the particles that aren't ingested, Madeline, is a really important one that folks would be concerned about, just like we always would be. And happily, or one of the elements of a successful pesticide or toxicant would be that it disappears, or it is broken down really quickly, right? And so I mentioned the lamprey, and we use a pesticide to affect the larval lamprey. They live as larvae between 3 and 6 years, filter feeding in streams, and that pesticide is happily also very selective for lamprey, which are primitive vertebrate and thus have some vulnerabilities that other fish don't have. So that's been the key to that success. And then the other really cool part about the compound is that it is really photoreactive. It breaks down quickly just by light, and then also bacterially. Its chemical composition is such that other organisms break it down quickly. So there aren't remnant of things, in the bad toxic. Many of the things that we talk about as toxics in the environment are often ones that persist, and happily it doesn't. So those are key ideas, but they're not. Believe me, we'd all you'd way rather not, put things in the environment if you could. But this idea of really focused, either genetically focused or as I just mentioned, this idea of compounds, microencapsulated focused techniques are very appealing. It's just that they're tough to get in place and actually test. Yeah.
Sure. Thank you.
You're welcome.
I have a question. When they put in the St. Lawrence Seaway, were the Americans and Canadians ready to look at invasive species, or did the invasive species, come to a chaotic point, and then they started to get organizations or institutes up to look at the problem?
Yeah,
And
great.
the second part of the question is, how well prepared are we now on the Canadian side and the American side to go forward in the next 5 to 10 years?
Yeah, great questions. So I think what you would say is that no, there were organisms that had already occurred or were occurring when the canal was being sort of put in place, and their effects were being seen. So I mentioned the ale life, for example, in Lake Ontario, the shad that we knew in the 60s on the beach before, and just as the sea was sort of coming into play in full function, those organisms had already gotten in through the Erie Canal. So there was an understanding, an emerging understanding of what that would mean. But we mentioned earlier in our earlier question that we were still introducing European organisms without really an understanding about that broad impact. So we were folks were learning, ecologists and fisheries biologists and aquatic ecologists were learning about invasive species right at about the same time. The answer would be no, we didn't anticipate the entrance of organisms through the canal. But as that happened, and the sea lamprey is the poster child for that, especially above Niagara Falls, with the full well as the full current seaway was established, the locks were established at Welland. That changed the dynamic dramatically and focused people's attention. And I mentioned the Great Lakes Fishery Commission was actually formed to deal with that issue, because we can ascribe a full collapse of the top predators and valuable commercial fisheries to that predator as it was introduced. So that really turned the tide. But in recent years, by recent, then in the subsequent time, in the broad impact of all invasives was really starting to be understood. So I think we're never prepared enough, But the actions that are going on today, say around the new considerations by Transport Canada for regulation of the Shipping Act to fully join the convention on ballast water. That's a global convention by installing ballast water management on all ships and requiring in all ships in Canadian waters. There's an example of an effort to really prevent. And then the reaction and response side with the efforts of our friends that are working to detect aquatic invasive species really specifically on the US and Canadian side of the Great Lakes. We're in a really different place today, thanks to folks' words, and then public understanding changing the dynamic really, right? So a whole bunch of pieces have come in play. But we'll never be prepared enough, right? And there will be organisms that will get past us. But being just like our Mussel story, right, is a great one where just by attentiveness and folks' awareness has opened the door to potentially blocking a piece that who knows could have really amounted to important spread of zebra mussels, as it were. Yeah, so I think I'm generally optimistic around that. Now, like everything, we're trading the benefits against costs when we're taking actions. So that's part of the story as well. Yeah, great question. Thank you.
And Christina has another question there.
Yeah, sorry. So
No problem.
I was just thinking about microbiology actually, and how I know that a healthy flourishing population of bacteria is really resistant to invasive other bacteria. Do we notice the same thing in the Great Lakes, where a healthier native species population is more resilient to invasives? And how would that be affected if we manage to curb the overfishing of lakes, oceans, and seas of our area?
Yeah, great question. Yeah, thanks, Christine. That's a great point. Yes, on the finer points, lots of debate around that, but in broad sense, I think you're exactly right that stable and rich ecosystems that are well structured and functioning well are more resistant to change. Just like you mentioned, microbial populations, and then a place that we can all see it would be the vulnerability of disrupted ground to weeds, right? And to plant invaders, or to plants that are designed to colonize really effectively. And so yes, the answer is. Now, is it however, the science that folks have done in sort of fisheries and aquatic worlds would say that it's not quite enough to just have a robust community while being more resistant. Certain invaders will have the potency to be able to sort of overcome that, even that, as it were. But your point's a great one, that a healthy ecosystem broadly will function better and be more resilient, we would say, right, to other threats and to invaders. So that's a really nice point, and helps us think about approaches that do both really, right, that look to do preventing, but also then the restoration side, such that we're really achieving healthy systems.
Yeah, thank you very much. And are there programs in place where the Department of Fisheries and Oceans are intersecting between preventing invasive species and lobbying for that reduction in overfishing? Like, is that an adjective or a directive that's in place currently?
Yeah, it's two thoughts about that. Yes, the approach to fisheries management is being framed and taken on in an ecosystem fashion, Christina, which means that we're considering all of the impacts or effects or the influences on the fish and fisheries, which include the healthy functioning of the ecosystem. So the answer to that would be yes. Here in the province, just for resolution, our friends in the province of Ontario on the Great Lakes do the part about regulating how many fish people catch. So and I mentioned already, the province has its own invasive species regulations and work closely with us on the challenge. So the answer would be that yeah, absolutely, a long established ecosystem approach which considers all of those, the sort of the ups and downs of that story towards healthy ecosystems. If you read the ecosystem objectives established by the lake action and management plans, or the fish community objectives established under the joint strategic plan for lakes fisheries management, you'll see that language and just that kind of perspective. Great questions.
Great. I had just, oh, go ahead,
Thank you very
Noah.
much.
Thank you.
Just to follow up on lampricides. So lampricides I know are generic to lamprey, but we also have a number of native lamprey species, which are on the decline. Some of them have become species at risk themselves or are now listed as provincially rare, at least in Ontario. And have there been studies looking at the sea lamprey treatment programs and if they could be modified to not diminish the other native lamprey, which do not actually target adult fish, they're filter feeders?
Yeah, great questions. Thanks. Yeah, that's cool. Not so many people would know about native lampreys, so I'm impressed. That's neat. Yeah, absolutely. You are right around the vulnerability. You are right about the impact. So just as Noah mentioned, the lampricides are specific to lampreys because of their primitive characteristics of the primitive vertebrate. So the native lampreys are the same situation. There are native lampreys in the Great Lakes, just as was mentioned, really in a fantastic group of species. They're very, very interesting, because some of them just filter feed, as we said, just live their larval life and then emerge, like some moths, for example, metamorphose only to adult phase, only to breed. There is, however, one species, the silver lamprey, here in the Great Lakes that is parasitic and naturally parasitic. But interestingly, the difference kind of in terms of why is the sea lamprey petromyzin we call an invasive species compared to the native predator? Well, that organism has evolved with its prey and is and plays that parasitic role, which is sustainable essentially, as you know, right, with the prey organisms. Anyway, that's a bit of the lamprey history. But yeah, fascinating. A great question. Yes. I'll say two things. One, that happily the range of a number of the native species are more extensive in the tributaries. That is, they're more they extend more up into the minor tributaries or past barriers, either natural or man-made barriers in stream. So they're protected in that way. That is, those areas are not in many streams or river systems are not available to sea lamprey that have to migrate up. So that's a kind of a natural feature that protects some of them. And then the other feature is that of them is that we're able to, by understanding their abundance, to target and change the application characteristics such that we can avoid them. And then it's a great question and timely, in that we've just completed a studies and review of just that topic, and we'll be publishing those before too long here. The results of that work, which provides exactly, it addresses exactly that question around how we'd approach it, uses some modeling techniques and an understanding of the vulnerabilities, the toxicity that we've just been describing, and the distribution of the organisms, and does the piece to sort of say, are there techniques or approaches, and takes that challenge on directly. In Fisheries and Oceans, we have a really an interesting approach to applying science. So as you know, academically, we write papers and publish them like that. Well, we work as well to as well as publishing the science, we go to the stage of writing science advice in response to questions from the management sectors that are doing the work. So in response to the questions and answering exactly the question you asked, we've done some work in recent times, and we'll be publishing that under the Canadian Secretary for Science Advice here. You'll, if you sort of take a look or keep your eye open, you'll see that coming out in a couple of months, I think. Great question.
Thank you. I have sort of like a random fun question. So I have never seen like the radio tracker stuff for fish before. I know I've seen it, like you could like cement it onto like a turtle shell. I've seen that before, but I don't know how it would work with fishies. Do they eat it, or is it like an inert, like?
Yeah, that's a great question. No, we do a little surgery there and just tuck it in their tummy. So there are a variety of sizes, and they do a variety of things, right? And it's pretty fantastic. So we literally do surgery and surgically implant anesthetize the fish and surgically implant the transmitter in their abdomens. And a cool part about that story is that the grid that in the bottom of that figure was that was an example of the things, and there are a whole variety of sizes of them, and just like everything, right, getting smaller and smaller and smaller.
Right.
They can the signals can send a bunch of different things, but mostly we're interested in the location. But they can also do a number of things. They actually have radio acoustic technology like that is measuring the physiology of the fishes, so to understand whether they're stressed or how they're doing. And then really interesting that the technologies are kind of compatible, and we have on the Great Lakes acoustic tracking system, which is then internationally led, coordinated by the Great Lakes Fishery Commission, and so we maintain like networks, so we can then see the movement of fishes beyond and from our networks elsewhere. Throughout, it's part of the ocean tracking network, and they're doing the same thing in oceans. And it's really changed the way we think about fishes, because of course you forget that we could only catch, the only way to look at them was whether we caught them on a line or caught them in a net or observed them while diving or swimming. But today now we can really understand much, in much more detail, the characteristics of their behavior. So yeah, that works just like exactly the same idea. You've seen whales and other organisms that can come to the surface or they come to the surface regularly, and those signals are sent by satellite. Ours are then picked up by receivers that are hanging in the water column. We just float them down below at the bottom, and then have to go and pick them up. But some of them we can remotely do, and then some fish tags will record the journey of the fishes and then pop off and float on the surface, and get picked up by satellite from there. It's pretty cool technology.
It's really cool. Thank you.
You're welcome.
So I'll give a few more seconds for anybody to think of any last questions they've got. You've done a great job of handling them so far. It's been really interesting. Thank you.
Good, you're welcome.
Are we taking one last question?
Sure.
How do you liaison with fishing groups or friends of the Jock River or friends of the Grand Bank River?
Mm-hmm.
Is there an outreach there?
Great question. Yeah. Yeah, absolutely. My, folks involved in the direct programs, a couple of different things are, happen. One, always open and interested in advertising for people to have their eyes out, right? And aquatic invasive species and all invasive species is a great place to carry out community or / citizen science, where we're eyes on the ground that agencies and others and the Friends of the Jock River or wherever, right, of the Grand, are people that are going to be on the river. Same with fishers. A number of our findings on the carp species, of course, come from commercial fishermen who are on the water. I mentioned the tench, which is a minnow-like fish that we found here, and that was found by commercial fishermen.
Thank you.
So we have outreach to them and keep that dialogue going, kind of thing. Yeah, and then there's a hotline. I should have included in my note here, but if you look for invasive species, you'll see the provincial hotline. So there's a centralized reporting place. With all the agencies and groups use the same reporting central line, such that helps ensure that communication is going effectively right to the right group that's interested in responding. Yeah, thanks.
Awesome. Well, it was quite an informative and interesting evening tonight. Thank you so much
Good.
for coming out. I just wanted to say this one comment that was in the chat that I think should be voiced just for the recording purposes. Hannah had mentioned that if anyone is interested, there's a great book about pets such as goldfish and their impact on wildlife, and it's Unnatural Companions by Peter Christie. So if you're interested in finding out more about pets and how they impact, then that's where you go.
I agree. That's a good reference to bring to people's attention, Hannah.
Awesome. Well, I'll stop the recording here.